Hey, good morning. So, um, in previous class, Pawan asked a question, doubt, what is statistical data? What is meant by the psi that connects particle nature and wave nature statistical, right? So, statistical data in the sense, a probable data. That means when you take a particle behavior, so uh, particle behavior precisely or particle precisely can be identified by its position. Clear. So where is the particle in the sense you can identify the accurate position of the particle. Whereas wave, if you consider, you can say in terms of wavelength or direction along which it is traveling. There is no question of position for a wave. Okay. So wave is nothing but in general phenomena when particle is oscillating, that disturbance continues. The disturbance in medium is wave. So the position of the wave is not a question. There is no such thing like. Okay, so um, but position for particle can be specified. But here the thing is, moving matter, that is moving particle, has wave phenomenon. Means it is associated with wave phenomena. So how to identify its position and what its wave nature? So mathematically you have to connect it. That is done by wave function. So whatever the data it gives is probable data. Means uh, let me draw here only. Okay. For example, the wave is like that. Group wave or matter wave is like that. Where the particle is situated in that case? So approximately by seeing its amplitude, we can say it's probability of finding a particle, right? So that data is statistical data, which depends on probability functions. That is statistical data. Okay. So in the diagram, you can say somewhere there in that region, particle is present. It is not even exact position. That's what Heisenberg uncertainty principle came into the scene. Delta x, delta p, that is uncertainty in position is delta x, uncertainty in momentum is delta p. How much will be there? It is greater than equal to h by 2 pi. That is what that much uncertainty will be there in identifying its momentum and position. We'll see that with more applications, we'll discuss that uncertainty principle on Monday. Okay. So this is the statistical data, probable data, probability, not accurate. And that connecting its wave phenomenon, that is wave phenomena in the sense you have to know k value. You have to have uh, frequency, sometimes wavelength lambda is known, lambda is known. So interconnected things. Okay, x equal to a sin omega t, we write. It is purely for wave. There x is the direction of the wave, and if you take phase x equal to a sin omega t plus or minus kx, so y equal to a sin omega t plus or minus kx, y is the particle displacement, x is in which direction wave is propagating, y is what particle displacement. So that particle displacement and wave propagation, wave in which direction it is moving in terms of its lambda or in terms of its omega. We are explaining it. There we don't think of particle, anything particle about particle. But here important is moving matter. Moving particle is very important. So when particle is there, when particle is moving, the position also very important. Okay. So the particle data also very important. The particle nature also very important. See, transverse wave you take. Transverse wave is what? Just wave. The particle is not getting displaced in the direction of the wave. Particle in that case particle is get displaced about its mean position, whether longitudinally or lateral. Take transverse wave or longitudinal wave in any medium. Longitudinal wave in uh, gaseous medium, air. What is happening? Particle will move up to some extent and comes back. So, or you take any string, transverse wave is propagating along string. The particle in the string is getting vibrated, is moving up and down about its mean position. So there we don't consider of particle. We don't think of any particle nature. It is purely wave. But when electron is moving with some velocity, higher speeds, or any fundamental particle, then the wave associated with that moving matter, electron is moving, the wave also is there in that direction. So we cannot separate wave and particle, moving particle in that phenomenon. Okay, if a particle is stopped, rest electron you take, what is the how? There is no wave nature. So when wave phenomena, wave particle duality comes is when the particle is moving. So there these two concepts are connected using this wave function psi. Okay, that's why main here probability plays important role. That's why we call this psi connects these two things statistically, right? Okay, so students still joining. You tell to your friends to join in the class and complete assignments send to Balaji's or mail ID. It is very very important. Even you specify mention submission of assignments in your WhatsApp personal WhatsApp group. Your friends group will be there. No, it is compulsory to submit assignments. That PDF sheet is given by sir. Sir uploaded in it. According to that, you write it. Some of you people are writing very good and take a snap or cam scanner, use cam or any scanner PDF. Send that PDF to sir. Okay. After that, me and sir will evaluate it. Accordingly, some report will be sent to JNTUH if they ask. Right. Okay. So today, very important is particle in a box. Okay. Particle in a box. By seeing this heading, or particle in a potential well, particle in a one-dimensional potential well, three. Well itself, it is three-dimensional. Particle in a box. So there are a few comparisons. If you take a box, closed box, and if you keep a particle or any marble stone in that box, with this today's concept, particle in a box, that is a electron trapped in a crystal. You take any electron in the crystal. See, this theory, up to some extent, it is some mathematical values it gives. That is true. Eigen energy value of the electron, and so up to some extent wave function value. Up to some extent it is right, but the concept taken, it is further discussions are there that we don't have in syllabus. See, to explain the behavior of electron in any crystal, in a solid, classical electron theory is there. It is failed to explain some sort of things like why this classification has been made, because every solid will have electrons. When electrons are there, it should have conductivity, and each and every solid must behave as conductor. Why this classification has been done? What is the base? See, before theory itself, our people are have used these conductors, insulators, dielectrics. Without this theory, they used it. Even in before quantum mechanics, quantum theory itself, they used conductors. Iron used as conductor, copper used as conductor. But according to classical electron theory, some calculations are there. It gives equation for conductivity of electrons in the solids. Then it is failed to explain why this classification has been done, why the specific heat varies with materials, why temperature, the dependence of conductivity on temperature is different from different solids. For example, you take conductors. If you increase the temperature, conductivity of conductors decreases. Conductivity of semiconductors increases. You know that, right? Resistors are a little different. How you heat even, they don't conduct. So, why this happened? This phenomena was not explained by that classical electron theory. After that, quantum electron theory has come. It explained the behavior of electron in the solids, how much energy it may possess. It is true. Even in further advancements, also it is true. Based on this, further advancements have been discussed. Okay, it is true. Next is band theory of solids has been developed after this quantum mechanical theory. So to understand band theory of solids, this particle in a box phenomena is very important. Simply within 3-4 lines, I explain band theory of solids. In band theory of solids, um, mm, band is a potential region. Two bands have some separation. Between separation, well, more simply, two atoms. You take a solid, two atoms, two nuclei, positive and positive. Between these two, electron moves. When electron moves, electron suffers some potential energy due to these positive charge. Plus Q, 1 by 4 pi epsilon naught, Q1, Q2 by R, or simply Q by R, potential. Potential energy, if you take 1 by 4 pi epsilon naught, Q1, Q2 by R. So, R is the separation between these two atoms. When electron is moving from this atom to this atom, zero distance, half the distance, and R distance. So, divided by R, substitute the variation. So that varies in this manner, in the inverted U manner. Because if I write here, I don't have the sheet. That's why simply I'm saying in air. You try to understand. Simply, in band theory of solid, the potential energy or potential in the solid is not energy in the solid is not considered as uniform. This point you remember. Potential uniform in the sense potential energy is zero or potential is uniform means the electron need not do any work to move from one end to other. That concept is same. Equipotential surfaces. If you take a sphere, at the center of the sphere, charge is present. Any radius you take, any radius at the center of the sphere, charge is present. 1 meter you take, draw a circle. So on that circle, if you want to move another charge, unlike charge, if it is plus q, you take electron. How much work done you have to do move that charge on that circle? Because potential is same, you need not to do any work. Automatically it moves, has to. Equipotential surfaces. So that concept is considered in particle in a box case. But whereas in band theory of solids, those are not equipotential surfaces. Potential is not uniform, but potential is periodic. Means you take atoms system, array of atoms. When you take array of atoms, see between two atoms, how potential is varying. In the same manner, see, potential energy will be maximum at the center of the two atoms. Okay, how potential is varying between two atoms. In the same manner, potential varies between next to two atoms. In the same manner, next to next two atoms, potential varies. So variation of potential between any two atoms is same. That is periodic. Minimum, maximum, minimum. Minimum, maximum, minimum. Again, minimum, maximum, minimum, minimum, maximum. This is periodic, just like to and fro motion. You take any simple pendulum, at mean position, its displacement is zero. At extreme position, some 10 meters, mean 0, extreme 10, 0, 10, 0. For total oscillations, this is that value is continued if you don't consider this fluid resistance or those things in ideal case. So that is periodic in nature. That's why it is called periodic motion. Periodicity in the sense some particular parameter will be get repeated for many times or in same intervals of time or depending on the concept. Here that potential varies periodically between neighbor atoms, between two atoms continuously, an array of atoms. That is in a solid. This is the concept considered in band theory of solids. Then based on that, bands divided into band, conduction band, valency band, separations. If you have conduction band and valency band are merged in few solids, those are conductors. And in few materials, conduction band and valency band have less energy gap, so that when you heat it, when you give some energy to it, the electrons in the valency band will jump to conduction band. Those are semiconductors. You have, so you are not seeing my hand. So that much energy gap is there between valency band and conduction band. Example, diamond, 5.1 electron volts. If you want to make diamond a conductor or semiconductor, I mean, if you want to make electron in valency band of conduction band to jump into the conduction band of diamond, you have to supply energy more than that of 5.1 electron volts. It convert into joules, how much heat has to be supplied to it. Then it is cannot be a diamond. If you supply that much energy, it cannot be a diamond. It takes its form, actual form, becomes carbon. అంటే బొగ్గు కోల్ బొగ్గు అవుతుంది మొత్తం డైమండ్ గోయింది కాస్ట్లీ డైమండ్ కొని you can experiment it. Okay, so based on this band theory of solids, it is classified into these three categories. Clear? So now we'll come to the actual thing, the middle thing. Here what is our concept is, excuse me, here is a crystal. We are taking a solid, in that electron is trapped, that is particle in a box, right? How the box is, box has infinite wall. Infinite wall in the sense, in simple manner, you take a copper wire or any crystal, sodium chloride crystal or any solid, electron is present, right? Unless until you apply some force or some energy you give it, then only it will come out. Unless until you supply energy, it will be there itself. So the in solid electron is present, and here our assumption is that electron is free to move throughout the solid, but it will not come out because it is freely movable. Because electron moves freely, that means potential energy should be zero. Potential energy is what the work done required to displace an electron from one point to other point in a between two charges. That is the basic thing definition. So potential energy there zero in the sense work done is zero. Where the work done will be zero? Where equipotential surfaces or potential is zero. Okay, there potential where the potential will be there. Equipotential. At this position, how much potential is there? Here also same potential. So the energy to displace work done to displace the electron will be zero. Potential energy is zero. So here we take potential energy zero. Potential energy zero in the sense the uniform potential phenomena we are taking. And electron should will not leave that solid. What does it mean mathematically? Outside there is higher potential. Electron is there inside the solid. It is not coming out of it in the sense. Even it does not stay on the wall of it also. On inside wall of crystal solid also, electron will not stay. It hits and come back. That means what? Mathematically, what we can assume? This has infinite potential. So outside of the box, we take infinite potential. Inside of the box, we take potential is zero. Potential energy is zero. So dimensions of the box, L, length of the box is, or length of the crystal is L. This is the thing. Here we'll write their boundary conditions. What are the boundary conditions? V0, V0 inside box, V0 at x is greater than 0, that is inside the box, and less than L, inside the box itself, here, throughout the box. Now, V is infinite at x is less than equal to 0, less than in the sense this side, equal in the sense on the wall of the box, and also x is equal and greater than L. Equal in the sense on second wall, greater in the sense somewhere this outside of the box. Okay, these are the boundary conditions, right? So now electron is there, electron is present. With that concept only we are going. Again, we no need to we should not have any doubt whether particle is present in the box or not. Particle is present. Okay, right. So when particle is present, its Schrodinger wave equation will write. Okay, this is the Schrodinger wave equation in general. Let us apply to this case. In this case, what is V? V is 0. So now Schrodinger wave equation becomes b is 0. So d square psi by dx square plus 8 pi square m by h square into e psi equal to 0. Right. So here 8 pi square m by h square into e will take some constant. See, I don't write every time of x. Okay. Is there x? In the sense we are taking along x direction, one dimensional. Now, what will take as k square? Okay. So, when a differentiation equation second order differential equation is there, equation this equation A, it should have some solution. For that, we'll take possible solution. For that, we'll assume some possible solution, then we'll solve it. Okay. The possible solution for equation A, this Schrodinger wave equation, maybe like A sin kx plus B cos kx. Okay, this is one of the method to solve the double differential equations. Many methods are there. I think you know how to solve the second order differential equations. One of the method is we take in the form of trigonometric functions with the unknown parameters. Here we have taken a and b are the unknown parameters, right? In other cases, some exponential functions they take. In other cases, they apply the conditions. Okay, many methods are there. In this, let us differentiate this equation. Before that, one of the method is possible solution they will write. Single differentiation, double differentiation they do. They substitute in the actual given given problem, so that they will find out a and b some value. That is one method. But here we apply boundary conditions in the solution. Then we get a and b because boundary conditions are given. We'll do that. So here x equal to 0. What is the meaning of it? At x is equal to 0 in the sense on the first wall. On the first wall, particle is not present. At x equal to 0, as there is no particle, no wave function. So psi of x is 0. Let us substitute in this equation. Here we are substituting psi of x 0 because no particle is present, no wave function. Where the particle is not present, on the walls, x is equal to 0 is on the wall. X is equal to L is also is on the wall, right? And x is 0 is substituted, psi of x is substituted. Sin k into 0, sin 0 is 0, cos 0 is 1. So this term becomes 0. They have, we got b value. We got b value. Now let us apply second boundary condition. at x is equal to L. This is on the second wall. Psi of x is how much? L. And already we got B0. These three cases will apply again in this equation. At x is equal to L, sorry, at x is equal to L, psi of x is 0. Let us substitute. A sin kl plus b is 0, b into something 0 into something 0. So now we got a sin kl equal to 0. A sin kl equal to 0. A cannot be 0. If you make A 0, it is meaningless. Again, B already we got 0. Again, if you get A 0, total here psi of x becomes 0. Psi of x 0 in the sense there is no particle even inside the box. But that is not our assumption. What is our assumption? Particle is there. So A cannot be 0. Then what is the possibility? That sine function must be 0. Sine kl is 0 for kl values, integer multiples of pi, 0, 1, pi, 2 pi, 3 pi, so on. For that sine is 0. So from this again we got k. This k will substitute in equation 2, right? K square 8 pi square m by h square into e. Okay, pi square get cancelled. Remaining is, now let us write equation for e. This is energy of the particle or energy of the electron in that box. Okay, energy of the particle in the box. This is eigenvalue of that, in this case, eigenvalue, eigenfunction, right? This is true in further cases also. In band theory of solids also it is true. N square, h square by 8ml square, right? In three dimensions, if you consider, n becomes n1 square plus n2 square plus n3 square into h square by 8ml square in case of three-dimensional potential box. N1, N2, N3 gives their quantum numbers. Principal quantum number, azimuthal, those are there, no? Though those are the values for N1, N2, N3. And if you take 1, 1, 1 state, N1 equal to 1, N2 equal to 1, N3 equal to 1, that is one state. You take N1, 1, N2, 1, N3, 0. You take N1, 1, N2, 0, N3, 1. You take N1, 0, N2, 1, N3, 1. You get this. N1, N2, N3, 1, 1, 0. 1, 0, 1. 0, 1, 1. For these three represents three energy states. E 1, 1, 0, one energy state. So 1 square plus 1 square into h square by 8ml square. N1 square plus N2 square plus N3 square. Here I will write. This is in case of three-dimensional potential box. n1, n2, n3, three quantum numbers. n1 you take 1, n2 you take 1, 0, 1 1 0, 1 0 1, 0 1 1, three combinations. In these three combinations you will get same energy. E110 is equal to E101, that is equal to E011. Did you get? So these are called degenerate energy states. Degeneracy. Degeneracy is the having uniform equal energies among different energy levels. That phenomena is degeneracy. Degeneracy is having equal or uniform energy among different energy levels. D energy states is, these are the D energy states: 101, 110, 011. These three represents three different energy states of same energy. So these are called degenerate energy states. You can take any combination in that manner. Now you take 110 and 111, 110 and 111. And N1 you take 1, N2 1, N3 0. In the second case, take N11, N2 1, N3 1. These two are two different energy states. More clearly, 1 1 1, 2 2 2. N1 equal to 1, N2 equal to 1, N3 equal to 1. Again, next state, N1 equal to 2, N2 equal to 2, N3 equal to 2. Two different energies, and these two combination represents two different energy states. These two different energy states have different energies. This is called non-degeneracy. These energy states are called non-degenerate energy states. Non-degeneracy. Non-degeneracy is what? The energy, non-uniform energy or unequal energies among different energy levels is called non-degeneracy. Right? So, uh, next wave function we have to discuss, that we can discuss tomorrow. After that, tomorrow this is Monday. After that, we'll discuss Heisenberg uncertainty principle also. I think now it is 12 and you have class again, no? At 1, 12:30 or something like. Okay, no problem. Just practice it. Okay. Tomorrow I change the sheet. Tomorrow we'll discuss that wave function and also this again degeneracy, non-degeneracy cases, and also how Heisenberg, that spin quantum number, Heisenberg uncertainty principle here, how it is taken. Also we'll discuss what is actually Heisenberg uncertainty principle, basic thing. Okay, which is required for your examination purpose. Okay, and mathematics based on that if time permits. Clear? Okay, as I said earlier, in every class, practice yoga in the daily, in the morning. That link I shared in Facebook link, just follow it. Just play the video. Many techniques are there. You follow it. Ask your parents to practice that, so that physically and mentally it will be good. And you have to free your knee joints. Many exercises are there with breathing pranayam. Okay, and soon I think on 5th our government going to decide whether to extend or whether to relax the thing. And as central government declared by the zone system, our Hyderabad came under into red zone. So they will see for 21 days. If no more corona cases are reported, then they change into orange zone. Or otherwise, it will be continued as red zone. If it is changed to orange and green zones, then soon you will have examinations. That's why I'm giving this thing information. Till if it is continue in red zone, doubt, but prepare for examination. Maximum in the month of July, as UGC said, examination will be there. Don't delay. Okay, don't postpone your studies. Daily one topic you study, because anyway classes are going. These classes parallelly you read. Today's class, after completion of class, just go through this derivation what I taught. Similarly, mathematics, PPS, drawing. Okay, don't forget to submit assignments. Today I will give one more quick assignment based on that. Yesterday I shared that. I think yesterday I not forgot, due to some connectivity problem, and I'm busy with other works. Your work only. I'm preparing some PPTs for you people. Okay. Anyway, good day. All the best. Read it tomorrow. Maximum by I will try to come 11. Otherwise 11:30 will start. No problem. Right. Good day.